Now we're going to talk about a method called reduction of order. Now in this method, you already have to have a solution especially to the homogeneous case. To the homogeneous case, even if it's homogeneous or if it's non-homogeneous. So we start off with a solution to the homogeneous case, and we're going to find another solution where we have u as a function of x times the solution we already have. And then eventually we're going to use the substitution w equals u prime. So I picked out two examples. I picked out a homogeneous case and a non-homogeneous case. So let's do the homogeneous case. Now again, in this method, you have to be given a solution already in order to find, like in this case, it's a second order, to find another solution. And by the way, this is used to prove, and one thing I have not said is that the other solution will be linearly independent of the first solution. So this is used to find a linearly independent solution, and it's used to go on to other methods. So I'm going to take y sub 1 equals e to the x over 3, and I'm going to plug it in. I'm going to plug it into my formula here and then plug it into the differential equation. So y sub 2 equals u times e to the x over 3. Now this y sub 2 is supposed to be a solution to this differential equation. So I need to take the second derivative, the first derivative, and plug them in here. So let's take the first derivative. Well, I'm going to have to use the product rule because u is a function of x and e to the x over 3 is a function of x. So first times the derivative of the second plus the second times the derivative of the first. So the product rule. Now, let's find the second derivative. Again, we'll have to use the product rule in both cases. So the first times the derivative of the second plus the second, times the derivative of the first. So this would be u prime over 3. So that takes care of that one. Now, flip it. The first times the derivative of the second plus the second times the derivative of the first. Now, let's plug everything into here. So let's plug all this into here. If you notice, this term and this term are exactly the same. So let's start off with this guy. And what else do I notice? I notice an e to the x over 3 is in every term. So why don't we, just to make things simpler, factor out the e to the x over 3. So e to the x over 3 times, I've got a u double prime, and this is all times 6. So let's do 6 u double prime because it's 6 right there. So 6 u double prime, so that takes care of that guy. Like I said, this is duplicated. So this would be 6 times 2 of these, so that's 12 over 3, which is 4. 12 over 3, which is 4 u prime. Because again, this would be 2/3 times the 6 would be 12/3, so that's 4. And then 3 times 3 is 9. 6 over 9 is 2/3. Okay? So that takes care of every term. Now plus y prime. Again, I'm factoring out e to the x over 3, so this would be plus u prime plus u over 3. Then finally, minus y, so that'd be minus u. So that's what I've got right now by plugging all this into my original differential equation. Now here is the key part. If this does not happen, we've done something wrong. U to the 2/3 plus u to the third is u. minus u gives me 0. The u's must cancel out. No sheep, no u's. Okay? So now that I have the u's cancel out, let's add up the other parts. So this would be e to the x over 3 times 6 u double prime. Then I have this 4u prime plus that u prime would be 5u prime equal to 0. Now let's plug in w equals u prime, and then let's cross multiply by the e to the x over 3. Of course, times 0, you're going to get 0. So what do I get? 6 double prime plus 5w equals 0. So let's get it in a form that I'm familiar with. Divide everything by 6. So I get double prime w prime plus 5 6 w equals 0. Well, I know what type of problem that is. That's an integrating factor. That's linear. So that's mu, and you can look at it. It's going to be e to the 5 6 times x. So I've got my mu. So what do I get? I get the total differential of the unknown function, which is w, times the integrating factor e to the 5 6 x equal to, and this part's easy, e to the 5 6 x times 0, you get 0 dx. So integrate, so you get w e to the 5 6 x equals c. Okay? So w, which again was what? U prime equals c times e to the negative 5 6 x. So therefore u equals c1, because the negative 5 6 I have to have, and so multiply by negative 6/5 changes the arbitrary constant. It's still an arbitrary constant, but it just changes it. So I get negative 5 6 x. All I did was integrate. That's all I did. And I took the constant and put it into the arbitrary constant. So u, so y sub 2 equals u c1 e to the minus 5 6 x times e to the x over 3. I'm doing this right here. So what do I get? Well, I get c1 e, and what are you going to do? You're going to add these two. So let's get a common denominator. So this would be x times minus 5 6, multiply that 2 over 2, so that'd be 2 6. So c1 e, you get negative 3 6, so that's negative x over 2. So what have I found? I've found another solution to this differential equation, and this one is linearly independent to the first one. So by the way, I've got this. I've got the general solution being c1 e to the x over 3 plus c2 e to the minus x over 2. So I've got my general solution to this differential equation by using this reduction of order. Now that's how you do it with a homogeneous case. How do you do it with a non-homogeneous case, and what do you end up with? Well, this is the nice thing. Not only do you end up with another solution to the corresponding homogeneous differential equation, but you also end up with a particular solution. So this is a solution to the corresponding homogeneous case. I'm going to end up with another one because it's second order, so I need another one, but I'm also going to end up with a particular. So let's write y, and I'll call it still y sub 2 is equal to u times e to the x. So y prime sub 2 This one's easy. So this be first times the derivative of the second plus the second times the derivative of the first. That's easy enough. So then y sub 2 double prime, again, first times the derivative of the second plus the second times the derivative of the first times the derivative of the second plus second times the derivative of the first. So that was very easy since it's e to the x, and the derivative of e to the x is e to the x. So I'm going to take everything and I'm going to plug it in here. I'm going to do what I did on this other example. Everything has an e to the x in it. So I'm going to pull out the e to the x. So it would be y double prime. Again, I noticed that there's two of these guys. So this would be u double prime plus 2u prime plus u minus 4 times the first derivative. So that'd be minus 4u prime minus 4u plus 3 times the first one. And that's supposed to equal x. So let's see what we get. Let's make sure everything cancels out. Well, a plus u and a plus 3, that's 4u minus 4u. Yep, the u's cancel out. Again, I remind you, you've done something wrong if the u's don't cancel out. If you still have baby sheep, you've done something wrong. So now plug in w equal to u prime. So I have e to the x w prime, and this is minus 2w equal to x. So I get that. So now let's take the e to the x over the other side. So this becomes a e to the minus x right there. So I have, again, a linear integrating factor problem. So in this case, mu will be equal to e to the minus 2x from this guy right there. So what do I get? I get the total differential of w, the unknown function, times the integrating factor, e to the minus 2x, x, e to the minus 2x times e to the minus x is e to the minus 3x. So I see, guess what? Our favorite, integration by parts. That's right. So let's integrate both sides. So let's integrate this guy. So I'm going to let u, and I'll call it u, so let's call it w. Well, I've used w, I've used u, so let's call it p. P is going to be equal to liate, log, inverse, algebraic. So we'll call p is equal to x. dv will be equal to e to the minus 3x dx. dp will be equal to dx. V, integrate that, so you need a minus 3, so it'd be minus 1 over 3 e to the minus 3x. So this integral, just that integral, equals, so p times v, so that would be minus x over 3 e to the minus 3x. Minus a minus makes a plus. Integral, and I got a 1/3 in front, e to the minus 3x dx. So what do I get? I get minus x over 3 e to the minus 3x minus a third. I need a minus 3, so minus a third, so that'd be minus 1/9 e to the minus 3x. Of course, I get a plus c there. So when I put all this together, let's put it down here, I get w e to the minus 2x equals the integral over here. So I'm going to get a minus x over 3 e to the minus 3x minus 1/9 e to the minus 3x plus c. So W is u prime, and I'm going to take this guy and multiply it times the other side and substitute W equal to u prime. So let's delineate between what we did earlier. So this would be u prime equal to, well, look what I get. I get minus x over 3 e to the 2x times e to the minus 3x is of x. Here I'll get minus 1/9 e to the minus x, and here I'll get plus c e to the 2x. Okay? Now that I've got that, what do? U prime equals that, so I need to integrate. So I'm going to get u equal to minus 1/3 integral of x e to the minus x dx. This one I can integrate. I've got a negative, so that would be a plus 1/9 e to the minus x plus c1 e to the 2x. Again, 1/2 times c is c1. A constant times an arbitrary constant is just a new arbitrary constant. So this is the only one I have to worry about. So again, I'm going to let p be x. So dp equals dx. dv equals e to the minus x dx. So v equals negative e to the minus x. So this integral is equal to minus x e to the minus x. Minus a minus is a plus e to the minus x dx. So I get minus x e to the minus x minus e to the minus x plus c2. So u equals all this, so times a minus 1/3, so that'd be x e to the minus x over 3 minus a minus is a plus e to the minus x over 3 plus, I'll call this c sub 3. That's just, again, this interval. Now let's add plus 1/9 e to the minus x plus c1 e to the 2x. Let me delineate there again. So that's my u. Now I got to take it and multiply it times e to the x. Now watch what happens. So y, and I'll do it down here to give us a little more room. U, all this times e to the x. Well, what's e to the x times e to the minus x? It's just 1. So I get x over 3 plus 1/3 plus c3 e to the x plus 1/9 plus c1 e to the x times e to the 2x is e to the 3x. So let's put these together. I have x over 3 plus 1/3 plus 1/9. So that would be plus 4/9 if my arithmetic is correct, plus c3 e to the x plus c1 e to the 3x. Now here's what I want you to notice. This is the y sub c. That's the complementary solution. Second order, I have two linearly independent solutions. This is the y sub p. So what do I have in essence? I have the general solution to this differential equation. This is the general solution using this reduction of order. So a lot of stuff going on here. But the main thing is to use these substitutions, and you end up with another linearly independent solution for the homogeneous case. And if there is a particular solution, if you have a non-homogeneous case, you end up with the particular solution.